Good morning guys, welcome to Videos Online Academic Tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please do well to press subscribe button and notification bell in order to see all of our educative videos online. Please remember to share this video with your friends, families, relatives and colleagues at home. Thank you and God bless. Today we are going to be considering topic under what? Under chemistry. We are going to be considering the topic under chemistry. And this topic is tagged empirical formula, molecular formula, and determination of relative atomic mass of isotopes. The empirical formula has to do with the simplest ratio of what? Of a particular compound. It is the simplest form of any given what? Compound. While the molecular formula is the what? Is the multiple ratio of a given compound, and it's also defined as the actual formula of any what? Compound. Now, while the definition of relative atomic mass has to do with what? Isotopes. Now, isotopes are elements which have the same atomic number, but what? Different mass number, like in oxygen. Oxygen, we have oxygen 16 and oxygen 18. So these are called isotopes. They have the same atomic number, but different what? Mass number. So we are going to determine the what? The relative atomic mass of this what? Of these isotopes. And today we are going to be considering these 12 questions to solve this what? This concept of empirical formula, molecular formula, and what? And the relative atomic mass of what? Of a given what? Isotopes. Now, an organic compound has an empirical formula of CH2O and a vapor density of 45. What is the molecular formula? What is the molecular formula? Given that C is equal to 12, H is equal to 1, oxygen is equal to 16. Now, we are given that what? An empirical formula, that's number one, an empirical formula, EF, of a given compound is CH2O. Now, and we are also told that the vapor density is what? Is 45. Now, we are asked to calculate the molecular formula. Now, to get the molecular formula, note that what? Molecular formula can be obtained by what? By multiplying the what? The empirical formula by N and equating it what? To the relative molecular mass. Relative molecular mass. Now we are going to multiply this what? EF by N, and this N represents the multiple of the what? Of the molecular formula. So we are going to use N to multiply the what? The empirical formula and equate it to the relative molecular mass of the what? Of the compound. So when we do this process, when we carry out this process, we are going to obtain the value of N. Then we now use that N to multiply the empirical formula to get what? Molecular formula. So let's carry out the process. Now we are given the empirical formula of what? CH2O equal to what? Equal to vapor density. This vapor density. Now, vapor density is what? 45. Know that molecular mass is equal to what? 2 times what? Vapor density. The molecular mass of a compound. Molecular mass of a compound, relative molecular mass of a compound is 2 times vapor density. Vapor density, let me put detail. Vapor density. So note that is 2 times vapor density. So CH2O into bracket what? N now will be equal to 2 times 40 what? 5. Now what is our C? The atomic mass of C is 12. Plus what? The atomic mass of what? Hydrogen is 1. So in bracket 1 plus 16 into bracket what? N equal to 90. Now, what do you now get? You have 12 plus 2 plus 16 into bracket what? N equal to 90. When you add this together, you have what? 30N equal to 90. Divide both sides by 30. So 30. This one cancels out. N is equal to what? 10. So the N here is what? Is 10. So that's our multiple. So we now go back to the what? To the initial equation given to us, which is what? CH2O O into bracket. Now instead of N now we put 3. So you multiply out with 3. So 3 times C, C3, H. Now 3 times 2 is what? H6 and O3. So these are our molecular formula. MF. These are our molecular formula. So molecular formula here is what? Molecular formula here is option what? C. Is option C. Now the question number 2 says a compound contains 40% carbon, 66.7% hydrogen, 6.7% hydrogen, 53.3% oxygen. If the compound molecular mass is 180, compound molecular mass is 180, and its molecular formula is dash. The molecular formula is what? Dash. So we are calculating the molecular formula. Question number 2, molecular formula is unknown. But we are given percentage by mass of carbon. Percentage by mass. Percentage by what? Mass. Now, of carbon. Now, percentage by mass of hydrogen was also given. So let's put it carbon. Percentage by mass of carbon is 40 what? Percent. Percentage of hydrogen is 6.7%, and percentage of oxygen is 53.3%. Now, with that now, we can now what? Progress. And we are given what? The molecular what? Mass is what? Is 180. Before we can get the molecular formula, we need to get the empirical formula as we have said here. So we need to get the empirical formula. And how do you get the empirical formula from percentage by mass? The first thing you need to do is to divide percentage by mass by the what? Atomic what? The atomic mass of individual elements. Now, divide each element by its atomic what? Atomic mass. So it means that 40.0 divided by what is the atomic mass of what? Of carbon, 12. So 6.7 divided by 1, the atomic mass of hydrogen is 1. 153.3 of percentage by oxygen is divided by what? The atomic mass, which is 16. So you pick your calculator and then press. So now 40 divided by 12. I have 3.3 here. 3.333. So 6.7 by divided by 1 is 6.7. Then 53.3 divided by 16, what do you have? 3.331. Okay, now I haven't gotten this. Now you divide now. Now divide by the smallest what? Divide by the smallest. And divide 2 by the most smallest. So divide 2 by the smallest. We have, what's the smallest number here? 3.31. So divide 2 by 3.31. That is 3.31. Please note that. So 3.33 divided by 3.31. So 6.7 divided by 3.31. And then 3.31 divided by 3.31. Now when you press this on calculator, it's 3.33 divided by 3.31. We are going to have 1.006. Now this one will give you what? 6.7 divided by 3.331. This one is 2.011. Then the last one will give you ordinary 1. So if you see this value now, this can be approximate to what? 1. This one can be approximate to 2, and this one can be approximate to 1. This one is 0, 0, so it can be approximate to 1. This one is 0 to 2. This one does not have anything. You can also write it as what? 1. So this is the ratio. This is the ratio at which the what? The elements combine with one another. So the empirical formula will now be equal to what? C1H2O. So C1H2O. So that is the formula for empirical formula. Now the molecular formula will be now be what? Now you have to see CH2O. into bracket what? N now equal to molecular mass given to us, which is 180. So 180, comma. So now you substitute for atomic mass given to us. This is 12 plus what? 2 plus, because hydrogen is 1, just as we did here. Hydrogen is 1, 2 times 1 is what? 2. So plus what? Oxygen, which is 16. Into bracket N equals 180. Now 180. So we have 30N over 30. We have 30N. If we add this one together, it's 30 times 10. 30N equals 180. So if we now go side by 30, so we have what? N is equal to 180 divided by 30, which is N equal to what? 6. N equal to 6. Now, our final answer for the what? For the molecular formula will have CH2O into bracket what? 6. 6. Now, if you multiply this one by 6, it will give you C6. Multiply C by 6 by C. So this one will give you what? C6. H12O6. So this is a glucose compound. C6H12O6. So this is a glucose C6H12O6. Now, so that's that about question 1 and 2. Question number 3 says that an organic compound 60% carbon, 13.3% hydrogen, 26.7% oxygen. Calculate the empirical formula. This one question is only for empirical formula. We are told that an organic compound contains what? 60% carbon. Now, number 3, let's do it there. An organic compound contains what? 60% carbon. No. So this one is what? The percentage by mass of individual elements in the compound is given as follows. That is, the carbon has 60%, then hydrogen has what? 13.3%, then oxygen has what? Oxygen has 26.7%. So we are not told that what? Calculate the empirical formula. Now, if I was to calculate the empirical formula, the first is to divide by the atomic mass, just as we did the other time. Divide each by its what? By its atomic what? Atomic mass. So we have 60 all over what? 12, 13.3 all over 1, and then 26 over 26.7 all over 16. So what do we have now? So 60 divided by 12 will give you 5. Now this will give you 13.3. That is hydrogen. Now this one is 26.7 divided by 16 will give you 1.668. Now divide by the smallest. Now divide by the smallest. Now, if we divide by the smallest, it means that this 5 will be divided by 1.668. 13.3 divided by 1.668, and 1.668 will be divided by 1.668. So now, if we divide this now, so 5 divided by 1.668, what do we have? We have what? 2.997. Now, that's that. Now, for this one, 13.3 divided by 1.668. That is 7.97. So, and the last one is what? That will give us 1 automatically. So, now, this one can be approximated to what? 2.997 can be approximated to, if you approximate this what? 7 to this, to give what? 0, approximately to this will give you 0. This one will now become 3 because it is 10. So you carry the 1 to this place, which is 3.0, which is 3. And this one will be approximately 7 here, 7 to 9 to give you 10. Take it to become 8.0, and this one is 1. So it means ratio 3, 8, 1. So carbon is 3, hydrogen is 8 and oxygen is 1. So yeah, empirical formula is C3H8O. So which is option what? Option B. So that's that about that is option B. Now next question says an hydrocarbon has an empirical formula CH. It has an empirical formula CH and a vapor density of 39. So an hydrocarbon has an empirical formula of what? CH and a vapor density of what? 39. Determine the molecular formula. This also is very, very simple and straightforward. So since number 4 of this, we are told that the empirical what? Formula of a compound or an hydrocarbon. Don't forget, an hydrocarbon is a compound of carbon and hydrogen. So the empirical formula is given as CHRB. So the CH now has the vapor density of what? Of 39. So we have CH in the bracket N, which is the empirical formula, equal to get the molecular mass now, it will multiply the vapor density by what? 2. So the relative molecular mass equal to the relative molecular mass of the compound. Now CHN equal to relative molecular mass of the compound, which is same as 2 times the vapor density. So 2 times 39. So we have 12 plus what? 1 is bracket what? N equal to what? 2 times what? 2 times 39. 2 times 39 is equal to 78. So we have 13n equal to 78. We have to by 13. So n is equal to what? 78 divided by 13 is equal to 6. So this one is going to be CH divided by 6, which is equal to C6. H6, it is benzene. This is benzene. So that is benzene. All those compounds that we have been doing as what? As name. So well, we are not asked to name them. So number 5 here, which is an element contained what? 90% of what? Z16.8 and 10% of what? Z18.8. Its relative atomic mass is dash. Now, this question is not an empirical formula question, but is what? Is an isotopy what? Question based on an isotopy. Now you can see that element Z has what? An isotopes of what? 16 and 18. But now we are talking about an isotopes. An isotopes is an element that have different mass number but the same what? Atomic what? Number. You can see that this one has mass number of 18, this one has mass number of 16, but the atomic number is what? 88. While the mass number is 16, 18. So how do you get the relative atomic mass of this what? Element? Now what we are going to do is just to what? We are told that what? This one contains 90%, this one contains what? 10%. So this one is 19%, 90%. This one is 10 what percent. Just to find the 90% of the what? Mass number, 90%. So the atomic mass, which is what? The relative atomic mass, which I denote by around here, is equal to 90% of 16 plus 10% of 18 of the mass number. So meaning that I'm going to multiply 90 over 100 by 16 into bracket what? 10 over 100 plus what? Times what? Times 18. I'm going to press it at once. RMM, this one cancel out. This one will give me 0.9. So 0.9 multiplied by 16 plus what? Is 0.1 multiplied by what? 18. So open bracket what? 0.9 multiplied by 16 plus what? 0.1 multiplied by 18. Bracket close. This is 16.2. The answer here is 16.2. So what is the answer? You have 16.2. Option what? B. So question number 6. A silicon contained ore which has 92% silicon, 28, 55% silicon, 29, and 3% silicon 30. Calculate the relative atomic mass of the silicon. We have to calculate the relative atomic mass of the silicon. We are told that the silicon contains holes that has 92% 28 silicon, 5% 29 silicon, and 3% 30 silicon. Calculate the relative atomic mass. So we have what? Isotopes of what? Silicon 28, which is what? Which is 92%. Silicon what? 20 what? 9, which is 5%. And silicon what? Silicon 30, which is 3 what? Percent. It is 3%. So how do we go about this? Now we want to calculate what? The relative atomic mass. It will be the same procedure, which is what? 92% of the mass number of the first plus what? 5% of 29 plus 3% of 30. Now, meaning that what? We are going to have what? Following this now, you are going to have 92. Your relative atomic mass will have what? 92 over 100 multiplied by 28 bracket it plus what? 5 over 100 multiplied by what? Multiplied by 29 plus what? 3 over 100 multiplied by 30 brackets what? Close. So with that now we are going to have, now divide this will be 0.92 multiplied by 28, just about 9 plus, this one will be 0.05 times 29 plus 0.03 times 30. So when you press this on the calculator, what do you get? So open bracket 0.92 multiplied by 28 bracket plus open bracket 0.05 times 20 what? 9 bracket close plus 0.03 times what? 30. So what do we get? Everything is 28.11. So that is the relative atomic mass. 28.11 relative atomic what? Mass. So that's that about that. Lastly, number 7 says an element X has an isotope of X 2010 and X 22 what? 10. It has an isotope of what? X 2010 and X 2210. Present in ratio what? In ratio 1 to what? 3. So this one is a form of ratio. So not unlike before that we have percentage. Now the relative atomic mass of X will be what? Now this one is in terms of what? Ratio. What you need to do is to add the ratio together. 1 plus 3 is equal to what? 4. Then the relative atomic mass will be equal to 1 all over what? Because this one is 1 over 4 of the mass number plus what? This one is 3 over what? 4 of its mass number, which is 22. So we have what? 1 over what? 4 multiplied, because of is times 20 multiplied by what? 1 over 4 times 20 plus 3 over 4 times 22. So now what do you have now? This one will give you 5. Now this one is 5 plus, this one will give you what? 0.75 multiplied by 22. So to save our time, so what do we get? So 5 plus bracket 0.75 multiplied by 22 bracket close. We have for 21.5. So this is 21.5. So I've come to the end of today's class. Please remember to press the subscribe button, like the video, and share the video with your friend. See you next time. God bless you.